Hello, this is Zach Moore, and today I'll be covering the 502 programming language. It's a strongly typed language with a syntax reminiscent of Java and Python. It compiles to an intermediate language, and that is interpreted by runtime environment. I'll be covering the high-level language, the intermediate language, the compiler, and the runtime environment. What you're seeing here is an example of the high-level language. I have a function declaration here. Function declarations at the top level are global, so they can be called from anywhere. I have a class definition, which has a member variable and a member function. And then down here I have a main method that simply creates an instance of that simple class that we've defined there. It calls its member function, it sets its value for the int member, and then it prints that value. Just like in Python, member functions and variables in classes can be accessed directly. There's no need for getters or setters like in Java because there's no concept of private or protected. I also mentioned earlier that 502 supports templated types, which I have an example of here. This is a data structures example. I've created a stack that, remember, it's strongly typed, so we need to know what the stack returns and what you can add to the stack. They all have to be the same type. And to do that, we use templating. So we can make a stack of integers, a stack of booleans, a stack of stacks if we want, and we use this syntax to declare that. So here we've declared a stack of integers, and our main function, all it does is it loops for 5 times and asks the user each time to input an integer and pushes that value onto the stack. After they're done with that, it pops all of the elements from the stack and prints them one by one. So since stacks are last in, first out, we'd expect to get our input back in reverse order. So if we enter 1, 2, 3, 4, 5, we'd expect to get back 5, 4, 3, 2, 1. So here is my directory structure. I have examples here with our data structures source code defined in there. And if we open up a command line here, we can use the command compile 502, navigate to our data structures example, and compile that. So it'll expand out to a Python command because the compiler is written in Python. And we'll go through this process here and then translate it to the intermediate code. Now if we want to go back to PyCharm, we can open up the file that was just created. This is the intermediate code. As you can tell, it's an assembly-like language. It's very low level. Each instruction represents a very simple task that the runtime environment will perform. This push here represents a line number that will be jumped to after the main call ends, which in this case it's the end of the program. And if we go back to our command line, we can use the command run 502 and then type in the object file that we just compiled. There it is. And now it's executing. And so like I said, it will ask us for an integer 5 times. Our test case was 1, 2, 3, 4, 5. And when I hit enter, it'll print it back to us by popping the elements one by one. So it's printing 5, 4, 3, 2, 1 because it popped 5, popped 4, etc. I've also defined a recursive example. Here is the classic factorial example. It accepts a single integer argument and then calculates the factorial recursively. Our main method in this asks the user for an integer and then computes the factorial of that integer and prints the result. If we go to our command line, we can once again type compile 502, compile our factorials example, and then we can run it with run 502 and that same factorials file that we just did. Has us enter an integer. If we type in 3 times 2 times 1 is 6, so we should expect to get 6 back. We do. And we can run this again. Factorial of 5 is 120. So if we type in 5, we expect to get 120. And there we go. Real quick, we'll take a look inside the compiler. Here's the compiler source code. It starts by tokenizing the input, and it locates all the identifiers using this regular expression. It finds integer literals, and it also finds keywords. Then with that tokenized string, it comes up to our grammar here, and this grammar is used to generate a parse tree, which is then analyzed and translated directly into the intermediate language. That translation is done recursively, so it starts at the top node and it recursively calls functions down until it gets to terminal nodes. As I mentioned before, the intermediate language that it compiles to here is very low level, it's very simple. The compiler does most of the work. So if we look at our runtime here, down here we can see all of our instructions that are defined: access, assign, push, pop, add, subtract, divide, etc. They all correspond to a function. So all the runtime does is it loops through the lines of the program of the intermediate language, and it searches the first argument for this. So if it finds a command, then it executes whatever function is associated with the command. If it doesn't find a command, then it spits out an error that says the intermediate language is invalid. So that's all for this video, but please keep in mind that I have a checklist video that goes through all of the requirements for this assignment one by one and points to exactly where they are in my submission. So if you are struggling to find something in this, or if you think I missed something, please check the checklist video because everything's there. All right, thanks. Have a good day.